Have you ever watched a time travel movie and wondered, is that ever going to be possible? Well, the answer lies in Einstein's theory of special relativity. Firstly, this theory states that the laws of physics remain the same for all non-accelerating observers, and that the speed of light in a vacuum always remains constant. But what exactly does this mean? Einstein found out that as an object's velocity increases, so does its mass. He also found out that time will run slower for this object and the length of the object will decrease. But remember, this is only relative to the outside observer, hence the name relativity. These effects also only become apparent when reaching extremely high speeds, such as nearing the speed of light, which is around 300,000 kilometers per second or 186,000 miles per second. This theory also only deals with special cases, where the objects are in a constant state of motion, so either at rest or moving at a constant velocity. So first we look at time dilation, or in other words, moving clocks run slow. To prove this, two atomic clocks were set to the exact same time, but one was sent onto an aircraft to travel at a very high but constant speed, while the other was left to be stationary on Earth. After flying for a few hours, it was apparent that the time of the moving clock was slower than the one that had remained stationary. What is really cool about this is that since all clocks run slower the faster they move, this includes our own biological clocks. This means that if you were to shoot off into space, traveling at a speed close to that of the speed of light for 20 years, by the time you return to Earth, everyone else would have aged 20 years, while you would have only aged about 2. You would have not noticed that time was going slow. In fact, you would think that you were only traveling for 2 years. So, if you think about it, you actually traveled into the future. Another effect of this theory is something called relative mass gain. As an object travels faster, its mass increases. The reason for this is shown in Einstein's most famous equation, E equals mc squared. This basically means that mass holds energy and that mass and energy are interchangeable. And since the speed of light is a constant, this means that if an object has more mass, it holds more energy, but also that if an object has more energy, its mass will be greater. As the object would increase in speed, it would gain more kinetic energy, therefore increasing its mass. So the faster an object moves, the more mass it has, and therefore needs more energy to move it forward, which makes it nearly impossible for any object with a mass to travel at the speed of light. Lastly, when an object travels faster, length contraction occurs. This means that to an observer at rest, relative to the moving object, this object would appear to be smaller. So, to put all these three things together, think about it this way. You and your friend are each in your own spaceships, and in each of your spaceships there's a light beam bouncing between two mirrors. But say your friend's spaceship then starts moving at a high velocity. The light beam in your friend's spaceship will now have to cover a greater distance but in the same amount of time, since the speed of light is a constant. The only possible way for this to happen is if time for your friend were to go slower and the distance between the two mirrors were to decrease. Therefore, you would notice time going slower for him or her, and that he or she and their spaceship is smaller. These things sound a lot like something you'd watch in a sci-fi movie, and maybe in the future we'll find a way to travel at such high speeds, stopping time altogether, and maybe even travel into the past.